Good evening. Today we are going to see NPTEL assignment number 6. So part A we have. Now in this first we have choose the correct influence line diagram for shear force at point C of the following beam. So now if we will draw the diagram, then we have diagram in this fashion. So we have to move unit load. So this is 1. So if we have at C, this is 14 meter, this is 6 meters. Now, if I will draw a reaction, then we are going to say this is RA, reaction for A we have in this fashion. Now shear force at B we have minus RB, so I will draw this reaction, that is ILD for RB below. So this is 1, this is 1. And then we have to plot shear force, so we will take it down. Now we have this 6 meters, so this value will be, so for 20 we have 1, so we have 6 by 20, and this comes 0.3, and this is 14 by 20, this comes 0.7. And when unit load between A to C, we have shear force equal to minus RB, therefore we have plotted below. And when shear force is C to B, we have shear force that is equal to RA. So this portion. And therefore we are going to get shear force at C. If I will plot, then we have shear force at C, this is 0.7. Then we have to go up, that is given 0.3. And then we have 0. So this is ILD for shear force at C. So we have option, so you can see we have this option, that is B. So we have option B. Then we will go to the second, the maximum shear force at point C in the beam shown in figure if a uniformly distributed load of 10 kilonewton per meter of length 5 meter moves on the beam right to left. So now we can see shear force at point C. So we have this one from right to left. And then if we will put this shear force, so now we have this as 0.7. So this is 0.3, this is 6 meter. So if we will go for area of this, so this is 6 meters. So now if I will consider 5 meter for this, so we have this will be 0.3 by 6 into 5. And then we will get it as 1.5 by 6. And that comes 6 2s and 6 5s. And then we can have this area 1/2 into summation of parallel sides 0.3. Sorry, this is 1 meter. So this is 1 meter. Because this distance, this we have to consider, not 5 meter. So similar triangle. So we have 0.3 by 6, and that is y by 1. So 1 goes on this side and it comes 0.05. So this will be 0.05. So this will not be there. And therefore we have 0.3 plus 0.05 and multiply 5. And from this we will get, this will be 3.05 into 5. 3.05 into 5 divided by 2. So that area comes 7.625. And if we will be on this side, so if I will consider 5 meter on this side, and in that case, I will get this value. Now I will not calculate it. I have already calculated is 0.45. And then if we will calculate value of this, now this is 7.625 and we have load as 10. So this is 3.05 into 5 divided by 2 and multiply by load is 10. So second we have this. So area we have this. So you can see ordinate we have larger than this, and therefore we will get this as 1/2 into 0.45 in plus 0.7 into 5. So this is actually 0.35 into 5 divided by 2. So it comes actually this we have committed mistake. This I have taken 3.05. So this is equal to 1/2 into 0.35 into 5. And this area comes 0.875 and this area comes we have 0.45 plus 0.7 into 5 by 2. So this comes 2.875. So we are going to get this value greater one. So we will have this area 2.875 and shear force equal to 2.875 into UDL is 10 and we will get it as 28.75 kilonewtons, which is our option A. So we have option A. Then we have third, choose the correct influence line diagram for the shear force at point D for hair. Now we have shear force at D. Now we have when unit load A to D. Then we have shear force equal to minus RB. And when unit load is unit load between D to B, shear force equal to 1 minus RB. Because we are going to consider part only this part. So this is RB. And we have this is point D we have over here. Therefore, shear force is simply minus RB. And after this, we have unit load on this side. That is 1. And therefore, we have 1 minus RB. Now, if we will see the ILD for RB, then we have this value. So we have 0 at this and 1 we have at this. So now if we will calculate it, then we will get shear force in this fashion. D to C, we have RB0. So we have value as 1. So I will mark this as D to C. So if we will go to this, so we have this is point D, this is point C. D to C, we have RB0. So we have this value 1. And after this, we have one value at RB. So we will get 1 minus 1 becomes 0 and we will have diagram like this. On this left of D, we do not have anything. And then we will have this will be A. So we have solution is A. Then we will go with 4, the maximum bending moment at point D of the beam shown in figure 3 due to live load more than this span. Now we will go for bending moment at D. So we have this will be RB. We have this as point D and this is C. Now if we will see the distances, we have 8 meters. Then we have D to C, we have 4 meters. And sorry. Yes, 8 meter, 4 meter, and again 8 meters. Now, if we will draw the bending moment diagram, then what we will get bending moment diagram. So again, unit load A to D. We have bending moment equal to RB into 12. RB into 12. But A to D, we have RB 0. Therefore, bending moment 0. Now, if we will say unit load D to B, then try to understand what will happen. So if I will draw this diagram, we have this will be RB. I have this as point D, and unit load, this is C. So 4 meters, and this is 8 meters. Now we have unit load somewhere here 1. This is X. Then what will be my bending moment? So my bending moment equal to RB into 12 minus 1 into X. Now if we will put values at different point, then we will get at D, we have X 0. And therefore we will get bending moment equal to 0. Because RB, if I will plot, we have RB in this way. This is point C, this is point D, this is point B. So value of RB D to C is 0, and therefore we will get at D value as 0. Now at C, we have X equal to 4 meters, but we have value of RB again 0. And therefore we will get bending moment that is equal to minus 4 kilonewton, 4 ordinate we have this. Now when we have at B, we have X equal to 12 meter and RB 1, and therefore bending moment becomes 0. And therefore if we will plot bending moment diagram by plotting this, then I have bending moment diagram for this. So we are in this way. This is point D. So this is 4 meter. This is 8 meter. This is 8 meter. And we will get this bending moment diagram that is equal to, we have at D it is 0. Then here we have 4. Then it is 0. So this is 4. And then we will get maximum bending moment equal to 1/2. Base we have 12, height we have 4, and load we have 5. Then we have 2 6 are 6 5 are 30 into 4 120 kilonewton meter. And my value is C option. We have C, which is 120 kilonewton meter. So these are the 4 questions which we have, that is from assignment 1. So in second part we will go for other questions. Thank you.